Hello students, welcome to the lecture. Today we are going to study path functions and point functions. This is very important concept to be considered before studying first law of thermodynamics. For that, let me consider this example. Now let us understand the diagram first. Now I want to show one of the property of system along x-axis. Suppose this is x property, and one more property of the system along y direction, that is y is the second property of the system. It may be a pressure, volume, temperature, etc. Now system is in first initial state, and slowly it will move from state 1 to the state 2, and it will reach to the final state 2. Okay, when system is in initial state, then its properties are defined as x1 y1, and when system reaches at final state, that is at 2, its properties are defined by x2 y2. Now let us consider that when system moves from state 1 to 2, some amount of heat is given to the system. So now let us imagine that a gas cylinder, which we have already considered earlier, to that gas, if we provide external energy, then what will happen? Gas molecules will absorb that energy, and then those gas molecules will do certain work. Okay, so when system moves from a state 1 to the state 2, then if we provide certain amount of energy Q, then for that energy provided to the system, it has to do certain work. Okay, so let us consider there is a heat transfer from 1 to 2, and let us consider a work is done from 2 to 1. Now instead of following a path A, because the path which now I am showing is path A, so instead of following this particular path, if system follows path B, so while moving from system 1 to 2, and again moving in a reversible direction from 2 to 1, suppose it follows a path B. In that case, now the amount of heat transfer and the amount of work done both are different. Okay, so when system follows path A, then this work and heat transfers are different, and when system follows path B, then amount of heat and work transfer is different. It clearly indicates that heat and work both are path functions. These two are path functions. Okay, now you see these x1 and y1 for state 1, these values were same earlier for path A. Now even if we have changed this path to B, there is no difference in x1 y1 values, because these values are defined at extreme point of the path. Similarly, when we consider x2 y2 values, then these are also considered at an extreme point of this path, and therefore even if system follows path A or system follows path B, values of x1 y1 and values of x2 y2 will remain same. They will not change, and therefore these are called as point functions, as they have defined at points and not along the path. So even if you now consider any other path, so maybe a longer path, maybe a smaller path, x1 y1 and x2 y2 values will not change. However, work and heat transfer values will change. So this is what is called as a path function and point function. Functions those are path dependent are called as path functions, and functions those are point dependent, means their values will not change with change in path. Those are called as point functions. So when we will study further the first law of thermodynamics and few more examples, you will come to know what is the exact difference between path and point functions. Okay, before that we would like to talk about the sign conventions, because now we are going to consider heat and work transfer, so we should be very well aware of the sign conventions used for work done and heat transfer. Now let me consider this is the system, and the first point which we have to consider is work done by the system. So whenever there is a work done by the system is there, it is considered as a positive. And if work is done on the system, then it is considered as a negative. So these two signs are different. So if work is done by the system, then it is considered as a positive, and if work is done on the system, then it is considered as a negative. And this particular positive negative scenario is completely reverse for heat. In case of a heat, how? Let us see. So again I am considering the same direction of arrow. Okay, so this arrow indicates that heat is given out by the system, and it is considered as a negative, unlike earlier case. Okay, so in earlier case it was positive, so outward arrow was positive, but in case of heat, outward arrow is negative. So outward arrow of heat, what does it indicate? Heat given out by the system. And then what about inward arrow of heat? Inward arrow of heat, it indicates heat given to the system. So these are some of the things that we should remember. What is the meaning of outward arrow in case of a work? What is the meaning of inward arrow in case of a work? And same in the case of heat also. Now whenever you remember these sign conventions, always remember the case of work done, and you can just reverse it for the heat. Okay, even if you remember only one, that is work done by the system is positive, then work done on the system is always negative, and whatever positive negative signs used earlier for work are exact opposite in case of heats. Okay, so this is how you can remember the sign conventions, and we have to further use these sign conventions. Now before moving to the first law of thermodynamics, we have to understand one concept of cyclic process. So we are going to consider one of the cyclic process where system moves from state 1 to the state 2. Now I think up till now you have understood we are considering system continuously. We are considering system is moving from initial state to the final state. So this assumption we are going to consider continuously. So let us consider once again the same, that system is moving from its initial state 1 to the final state 2, during which work is done on the system, and according to sign convention it is negative. When system moves from final state 2 to 1, then heat is given out by the system. Heat is given out by the system, and its value is, sign convention is again negative. Its sign is negative. Therefore, this is a thermodynamic cycle which is also called as a cyclic process. And in this cyclic process, we are observing that the work done is equal to heat transfer, taking into consideration their signs also. So work done is equal to heat transfer in case of a cyclic process. So this is one of the assumption, or this is one of the observation actually, and which is considered as an assumption in the first law of thermodynamics. So we covered almost 3 points here. One is about the path and point function. So functions dependent on path are path functions. Heat transfer and work done both are path functions. And there are point functions also. The properties, they are observed only at end points of system, that is initial and final state. Those are called as a point functions. We have to remember all the sign conventions for work done and heat transfer. And then this is one of the assumption which we have to consider in case of a cyclic process, that work done is equal to heat transfer, taking into consideration all the sign conventions. Okay, so now in the next lecture we will study about the first law of thermodynamics. So now here we will stop. Thank you.